continue to look at stats and probability number 5, which is analyzing scatter plots. But we're going to look at the third learning target today. And it states, I can create a line of best fit to approximate the linear relationship. So our goal is going to be to look at this scatter plot, determine where the best fit is for our line of best fit, and that will approximate the relationship, that linear relationship, that constant relationship between the data points in that scatter plot. So a couple of vocab words here. So trend lines, or in other books, it just kind of depends on what book you're looking at, calls it the line of best fit. So you'll hear me use it both ways, and it kind of just depends on what you're looking at. So when a scatter plot demonstrates a linear, and that's what we just looked at in the last learning target. So if you can look at a scatter plot and say, hey, yeah, that has a linear relationship, the data points form a straight line or close to a straight line. A straight line can be used to show the general pattern of that data. A trend line, or a line of best fit, is a straight line that should lie as close as possible to the points of data in the scatter plot. So we're going to look at some examples of lines of best fit or trend lines. And it says write yes or no to describe whether the line is a good fit or not, and explains. We're just going to talk through this. So if you look at this first one, notice the data does demonstrate a straight line, or a linear relationship, I should say. And the author here had drawn a line of best fit or trend line in the opposite direction. So does this line of best fit or trend line demonstrate or show the general pattern of the data? And I would definitely have to say no. Okay, so if you notice, first of all, it doesn't even have the same slope. This is a positive association. This line has a negative slope, so they actually are an opposite. If you look at number 2 here, same linear pattern here is going down, so you can see a linear pattern. Is it a general pattern? Yes, and there's some things we're going to start talking about, some tips when doing this. You want approximately the same amount of data points above and below the line. You want, of course, follow that same slope. So since this is a negative slope, or the data points are going negative, so as the x is increasing, the y is decreasing. So it's a good sign that we have a negative slope here. You want them approximately the same distance. So I always take the furthest point away. You make a vertical line here, and a furthest point away over here, which looks like that one. And those should approximately be the same amount, which kind of gives you a gauge if you're in the middle. So I would say yes, this one does do a nice job of showing the trend line or the general pattern of the data. If you look at this one, yes, again, this is a negative slope. So as x is increasing, y is decreasing, or a negative relationship here. But notice the trend line they drew. So they have a negative, which is a good thing. But is that line in the middle of all this data? And I'd have to say no. Or do they have approximately the same amount above or below? Or if you look at the furthest point, which might be this one right here, of course, there is none above, so that doesn't actually going to have this equal distance of dots above or below. So this one would be a no, even though it has a negative slope. If you look at these points, they are increasing, so they have a positive correlation. Okay, but if you look at the dots, same problem we had here at number 3, all the points are above, and it's not in the middle, so you don't have approximately the same above and below. So that would be a no. So I was kind of giving you hints. So here are some tips when considering drawing the line of best fit. So my first tip is determine the direction of the slope. And that's when I'm talking about if you're looking at your data and it has a positive association, then your slope better be positive. If you're looking at your data points and it has a negative association or correlation, then you better have a negative slope. Draw the line of best fit in the middle of the data points. And these kind of go the same, tip 2 and 3. and try to have the same amount of data points above and below the line. Now, I'm not saying you have to perfectly. So let's say you have 8 above and you have to have 8 below. That doesn't always happen that way. Maybe you have 8 above and 6 below. Okay, but it should be approximately the same. You shouldn't have like 15 above and 2 below. That means that your line is not in the middle of all the data points. Of course, you ignore the outlier. So if you do have an outlier, you just kind of ignore that. And the last tip is try to have the data points equal distance from the line. Meaning, and I kind of showed you that vertical distance, that has to be approximately the same. Again, ignore the outliers, but that kind of gives you a judge or a good idea that if you're in that middle of that data points. So we're going to practice one here. So this is my scatter point, and I'll try to draw. Actually, I'll grab my line here. Okay, so my line of best fit, I might have to do it a couple times here, but if you notice, it's a positive correlation. So yes, there's a linear pattern. If I do that really quick, you can see that I'm going to hit most of that data points. You can also notice that is positive, so my slope or my line of best fit here better be a positive slope. I'm going to approximate here, see if I can get it. And sometimes when you're doing it paper pencil, you might have to erase and start again. It just kind of depends. I might have it a little low here, but if we count 1, 2, 3, 4, that's pretty much on the line. 5, 6, 1, 2, 3, 4, 5, 6. So I have approximately the same. My only worry was if you notice these, they might be a little further away. So I might need to move my data. Can I just move that point? Oh, there you go. A little higher. That looks a little bit better. Now, is everybody's going to be the same? No. It just kind of depends on your graph. I could sit here and play with this a little bit. You're not going to have the exact same line, but it should look approximately the same. So let's count here. Let's do a little math. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6-ish on the top. Definitely have a positive slope, positive correlation here. Distance, I'd say this one's probably my furthest. So if I take that vertical line there, and the farthest one over here is probably this one. So if you kind of look at those lines, are they approximately the same length? And they are. So I would say I did a pretty good job of getting in the middle. And I checked that by counting how many points above and below, and then kind of looking at that furthest point away, how far it is from that line of best fit. Last little thing we're going to do is just which line has a better line of best fit. And we kind of already did this at the beginning, but just to look at it one more time. So if you look at the data, they're exactly the same on both sides. Okay, you have a line of best fit. Your data has a linear relationship. It is kind of a line if you use a really thick paintbrush there. But if you look at this line, I wouldn't say that data is trending at a slope or a negative slope, or the steepness of the line is as good as graph B here. This one's a little slower slope. This one's a little steeper. I think that data is going down. I'm not going to sit here and count how many, but if I kind of glance at it, I think they have approximately the same on top and bottom of both examples. I just think it's that slope of the line that merely makes a difference. So notice even if I counted these and they have approximately the same, it's still important that you look at that slope of that line. How much steepness should be on that line. So why did I choose graph B here? I would most importantly, I'll try that again here. Most importantly, I think it follows the slope the best. Follows the slope the best. And then you could talk about the middle. Even though this first graph does kind of look like it's in the middle, it's that because that line of best fit. So of course you could add to that, the line is in the middle of the data points. Say approximately the same amount on top and bottom. We'll say above and below the line. And then finally, equal distance. I didn't check that, but I'll show you here. Distance. So if we go back up here too, let me pick a different color. So if I find the furthest away, it looks like this line. So if I make that vertical line here, if I go over here, it's a toss-up between, but I think this one's longer. So if you look at those, you don't have to get a ruler out, but you can just kind of visually see it. That's really good equal distance between those two.